Okay, so the second half of this section is on the quotient rule. So if you have two functions that you're dividing, um, just like multiplying, it's not as simple as take the derivative of the numerator and the derivative of the denominator and then divide them. There's a slightly more complicated formula. And again, we'll write this one in a less complicated way. This is the way the book presents it. So I put it on here this way, but I think it's a little bit easier if we do this not using f of x and g, but let's use well we could use f and g again, but not the d over dx notation. So let's see, we'll just write this here. So we have function f divided by a function g, and I would kind of recommend, because this is a little bit more complicated than the product rule, and it does matter which you do first. So with the product rule, you're adding the two components of that. So it doesn't really matter which you do first or second. With this one, you're subtracting, so it does matter which you do first. And so the way I kind of say this to myself as I write it is we have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. All right, so however you want to remember that, gf prime minus fg prime over g squared. I mean, you can say it like that, but probably have some way that you can kind of say it in your head as you write it. And I think that helps. That always helped me remember it. So, but this one is specific because obviously if you put fg prime first, then the answer is going to be wrong. It'll be negative instead of positive, or vice versa. All right, so let's see how this works. And this one's pretty easy to figure out which function is f and which is g, clearly. So what we're going to do here is we're going to have the bottom, so x cubed plus 6 times the derivative of the top, so the derivative of x squared plus x minus 2. So that would be, just use the power rule term by term. So we have 2x plus 1 minus the top times the derivative of the bottom, which is just 3x squared. And that is going to be all over x cubed plus 6 squared. And so now it's just a matter of simplifying this numerator, which is a little bit complex. So let's FOIL out these two. So we get 2x to the fourth plus x cubed plus 12x plus 6. And then we'll FOIL out, all right, we'll distribute the 3x squared. So you have 3x to the fourth plus 3x cubed minus 6x squared. Now, unlike, I should say, unlike when you do a difference quotient, for example, or you're finding a derivative using the definition of the derivative, and like all the terms in the numerator without an h will cancel out. There's nothing like that here. So this could, you could have no terms cancel out. You could have all the terms cancel out, I guess, or none of them, or whatever. It could be any combination of in between. So you can't just, you just have to simplify this like any algebra problem. There's no shortcut here. So combining our like terms, we have 2x to the fourth minus 3x to the fourth, so that'd be negative x to the fourth. X cubed minus 3x cubed, so minus 2x cubed. We got the x squared, so that'd be a negative, so plus 6x squared. And then these two, I think, are just going to stay the way they are. So plus 12x plus 6, and then all over x cubed plus 6 squared. And I think usually probably nothing will cancel with the denominator. It's not that it's impossible, but most of the time you can just kind of leave the denominator the way it is and not worry about it. Although, I mean, it is possible, but I think if something's going to factor and cancel, it will be pretty obvious. And we're not used to factoring fourth degree polynomials, so probably nothing to worry about there. Assuming I did this one correctly. That's another thing is the algebra on this one. You got to be careful and make sure you're not. It's easy to make simple mistakes, I should say. All right, so this one, find the equation of the tangent line for this curve at that point. So obviously use the quotient rule. So we have the bottom times the derivative of the top minus the top times the derivative of the bottom, and then all over the bottom squared. Now with this one, I think because we're going to plug this in, we're not really interested in the derivative as a function. We're really interested in what is the slope, because we need the equation of the tangent line. So we need the slope. We need the slope at this point. So I think what's best is to go ahead and plug in 1 for x. So let's plug in 1 for the x. I mean, you could simplify this. There's no point in really simplifying it. Just plug in the 1. So you the first minus, that would be 2e over 1 plus 1. And so we actually get 0 here. So we have 2e minus 2e. And so our slope is 0. And so then we're just going to have y equals e over 2 for our equation. So normally you would do kind of the point slope form. But if this is 0, then that side is just 0. So we have y minus e2, or y equals e2, e over 2. Okay. So I think we have maybe one more. And so this one is just kind of illustrate that you don't always need to use the quotient rule just because you could. This one, whenever you have a single term on the bottom, you can divide it into the 2 or however many terms you have in the numerator. So let's just divide the x into these 2, and we get x minus 3x squared. And now taking the derivative is very simple. So you can do the product rule if you like, but that's what you're going to end up with. And so if you don't need to use the product rule, if there's a simpler way to do it, then you should probably do it that way. Kind of like what I said on the product rule, quotient rule especially, the more you practice this, the easier it gets. And it's not hard, but you got to be careful with algebra. You got to know the formula. But if you have any questions or need any help, please give me an email.